Hello dear students, how are you doing? I'm very fine. Students, do you remember what we have seen in previous lecture? Very good. It was about one of the technique of integration by partial fraction. So today we will see the other technique of integration by parts. Integration by parts. By the way, this technique, the formula of this integration by part was derived by using the product rule of differentiation of two functions. So let's assume two functions here, u and v, be a function of x. Assume u to be it is a function of u of x, and v to be a function of variable x v of x. So if you remember in chapter 3, the derivative of a product of two functions is evaluated using this formula. So this will be it as the product of the derivative of these two functions is v times the derivative of u, that's v times the derivative of u, that means simply du by dx, plus u times the derivative of v, that is u times dv by dx. I hope you remember this. So from this we can derive the formula for integration of a given function by part. So to derive the formula, let's integrate both sides of this equation. When you integrate, you'll have this. It is the integration of du by dx of uv dx. This is equal to the integration of this expression plus the integration of this one. So if you remember, the integral is the reverse process of derivative. So let's see this one. You have u times v here, and its derivative of this expression, it is u v derivative. I can write in this form, or simply it is du by dx of uv. So the integral of this expression is simply it is the reverse process. The integral of this expression will be it is this one, uv. Therefore, the integral of this expression is it is simply it is u times v. So this is equal to v times, assume this to be du, and assume this expression to be dv. So you'll have this one. So now let's try to solve for one of the two. When you solve for, let's take this one, integration of u times dv. The integration of u times dv, this is equal to, you take this to the other side, so uv minus this one, the integration of v times du. So this is the formula for integration of a given function by part. This is a formula for integration by part. So to apply this technique, you have to be careful in selecting which function to be u and which function to be dv. So you will have this one of the function you let one of the function to be u and the other function to be dv, and then you apply this formula. So this is the technique of integration by parts. So from this, first you let one of the function to be u and the other function to be dv. From this you have to, by the way, after letting these two u and dv, you have to find du also here. From u you can find du because we need du here in this formula. You need du. Therefore, the derivative of u is this, simply let's see du, and we have dv here. So dv here, from dv, we need v also here. Therefore, we have the derivative. So, integrating, you have to find the value of v. After doing this, simply you can remember the formula easily. The integration of the original expression u dv will be, it is the product of the two u and v minus the integral of the product of the two functions minus the integral of v times du. So this is the formula to apply the technique of integration by parts. So let's see example for this. Let's try to integrate this function. It's integration of x times e raised to x dx equals to. Now let's try to find the solution. So in this case, to apply integration by part, you have to let one of the functions to be u and the other function to be dv. So let x to be u. We assume x to be u and this one e raised to x dx to be dv. So from this you can find du here. Du is the derivative of this expression. It is 1. The derivative of x, it is 1. And from this one dv, you can find v. That's the integral of this expression, the integral of e raised to x dx itself. So we have found this. After this, simply plug these values into the formula, this formula. The integration, therefore, the integration, you can apply this one. The integration of the function this, it's a product of these two. Thus it is x times e raised to x, x times e raised to x, minus the integral of the product of the two. This minus, this you take the product. Therefore, x times e raised to x here, minus 1 times e raised to x here in the integral. Therefore, this value is x times e raised to x itself minus, as you remember, the integration of e raised to x itself. And finally, we add c, the integration constant. Therefore, the integration of this expression x times e raised to x dx will be this one. This is the final answer. Now, let's try to evaluate this expression by changing the values of u and v, u and dv. Let's assume u to be the other one, e raised to x, and dv, assume dv to be x times dx, x times dx here. So from this, you'll have this one. The derivative of this expression du, it is e raised to x itself. We have dv here x times dx. So to find v, this is the integral of the expression. The integral of the expression, it's a power function. Simply you add 1 on its power, it's x squared over 2. This is it. So applying the formula, this one, you multiply these two, and then you subtract this one. Therefore, applying the formula, the integration of the question x times s dx will be e raised to x times x squared over 2 minus the integral of the product of the two, that is e raised to x times x squared over 2 dx. Look, this is not the final answer. When you go the same technique, if you follow the same technique to evaluate this one using this integration by part, you will not arrive at the answer. So the selection of u and dv matters in evaluating the integral using integration by part. Therefore, you have to select u and dv properly. So for that purpose, I'll give you a guideline in selecting u and dv. Now let's go to the guideline. Guidelines in selecting u and dv when you apply integration by parts. for integral of the form this polynomial times exponential or polynomial function times trigonometry sine x, either sine x or cosine of x, for this form assume u to be this one x, the polynomial part will be u and the exponential part will be this dv. So this one guideline. Now let's see another guideline. Okay, let's see second guideline. For integral of the form this one x raised to n ln x dx, in this case assume u to be ln x, and dv to be x raised to n dx. And let's see the other guideline, guideline number 3. For integral of the form exponential in trigonometry e raised to x sine bx dx or e raised to x cos bx dx, in this case assume u to be the trigonometric part, either for this case assume u to be sine bx, for this case assume u to be cos bx, and db in both cases dv is it is e raised to ax dx. Okay, so just please don't forget this guideline in applying integration by parts. Now let's see examples, additional example for this. Now let's try to integrate this expression x squared times e raised to x dx. So now this is polynomial times exponential, as we stated earlier the guideline. Using that, assume the polynomial part to be it is u, therefore u is this x squared, and dv the other part it is e raised to x dx. So from this find the derivative of this one, it is 2x, the derivative of this expression is 2x, and from this one antiderivative of the expression, the antiderivative of e raised to x dx is itself, that's this e raised to x. So applying the formula of integration by part, take the product of the two and then subtract the integral of the product of the two. So this just this one. Therefore here the integration of the question x squared e raised to x dx will be equal to the product of this one x squared and e raised to x minus the integration of the product of the two. That's these 2 times x e raised to x dx. But this is not the final answer. It needs further solving. So look this one. It is the integration of 2x times e raised to x dx. We have already solved it in a previous example, but now let's do it again. So to integrate this expression, it needs integration by part, this part also. So assume by factoring 2 outside, simply integrate x times e raised to x. So assume u to be x and dv to be the other part e raised to x dx. So from this du will be 1, the derivative of x 1. From this v will be the integral antiderivative of the expression, it is e raised to x. Therefore the integral of this x times e raised to x dx will be the product of the two, that is this x times e raised to x minus the integral of 1 times e raised to x, 1 times e raised to x dx. So this will be this x times e raised to x minus the integration of 1 times e raised to x is e raised to x, the integration of e raised to x is itself, it is e raised to x. Therefore we will have this one for this part only, just taking 2 outside, and so the integration of this part is it is x times e raised to x minus e raised to x times 2. Therefore, you'll have this one. You'll have this one. So it is x squared times e raised to x minus, you just factored out 2, so the integration of x times e raised to x dx. Therefore, this one is x squared e raised to x minus 2 times, just we have solved this one, the integration of x times e raised to x dx will be this, x times e raised to x minus e raised to x plus some constant c. So this is the final answer for the integration of x squared e raised to x dx. Okay, now, so this is the final answer. You can factor, by the way, simply multiply minus 2 in the brackets. So minus 2 times this one, minus 2x e raised to x, minus 2 times minus e raised to x is plus e raised to x plus some constant c. So by factoring e raised to x outside, you will have this one, e raised to x times x squared minus 2x plus 2 plus some constant c. So this is the final answer. It's a final answer. So to avoid doing integration by parts several times, as you see here, we have just used one integration by part for original equation. Next, we have also just applied the integration by part for this. So we have to omit just this duplication. We will have another technique. That technique we call it is tabular method. So let's see that technique. So let's see integration using a tabular method. By the way, this method works. This method works for function of the form polynomial times exponential function or polynomial times trigonometric function. If you face such type of functions, so you can easily apply this method, tabular method, for integration. So let's see this tabular method using this example. Let's see this, the previous example is the integration of x squared e raised to x dx using tabular form. So to apply this tabular form, you have to put these three things. Here, alternate signs. Next, u and its derivative will be listed here, and dv and its antiderivative are listed there. So the alternate sign, you have to start from plus. So we have plus here. U, by the way, the selection of u and dv is just similar to the previous. So we said for this form, u is a polynomial part, and e raised to x will be the dv part. Okay, so u will be x squared here, and dv for this case, u is this x squared here, e raised to x will be this dv. So next to this, just list the derivative of this expression. So by just putting all alternate signs starting from plus, the first part plus, next minus. So the derivative of x squared is this 2x. The antiderivative, by the way, here, the antiderivative, the integral of the function, the integration of e raised to x is this e raised to x itself. Now continue this process. So plus minus next plus, the derivative of 2x is it is 2, and the antiderivative of this expression it is e raised to x. The indefinite integral of e raised to x is e raised to x itself. Now next plus minus, the derivative of this one is 0, and the antiderivative of e raised to x again e raised to x. So you just proceed this process until the derivative of the polynomial part be 0. When you get there, you stop there. Then you apply this. The answer, just finally, just using this arrow, you can easily put the answer of the integration of this expression. Therefore here, the integration of x squared e raised to x, this one, the integration of x squared e raised to x will be is equal to the positive of the product of the two, x squared times e raised to x. So here, x squared times e raised to x. Next, minus this one, minus of the product of the two. Yes, minus 2x times e raised to x. And then plus the product of the two, plus 2 times e raised to x plus some constant c. So this is the answer. By the way, the answer, the previous one, a little bit longer. This one is shorter. So it's better to use for such type of functions. Tabular method is preferable. Now, so this is the final answer of this integral. Now, to understand this technique, let's proceed to additional example. Example 3. Let's see example 3. Let's try to find the integral of ln x dx. To find the integration of this expression in the guideline, we put this one if a function had this form, some x the power of n times ln x. If a function of this form, you have to let u to be ln x. We say this one, you have to let u to be ln x, the other function to be dv. So to integrate this, by the way, this function, the integral of ln x dx, is a product of the function. You can just put 1 here. It is 1 times ln x dx. So from this, u will be ln x. So let u will be ln x, and dv to be the other part, it is 1 times dx. So from this you can find the derivative of u here, the derivative of u, thus it is the derivative of ln x, as you remember, is derivative 1 over x, and this one, the antiderivative of 1, it is x. So next to this, apply the formula. The formula for integration by part is this one. Just you multiply these two and you subtract the product of the twins integral. Therefore, the integration of 1 times ln x dx is equal to the product of the two, that is this, x times ln x minus the integral of the product of the two functions, this 1 over x times x dx. So this simply, you can cancel x by x, and you have 1 here. The integral of 1 dx is this x. Therefore, the answer will be, it's x ln x minus the integral of 1 is, we say, x plus some constant c. So this is the integration of ln x dx. Now let's add more example. Let's see this one, the integration of the logarithm of x dx. Okay, to integrate this, let's use logarithm rule. I can write this logarithm, the logarithm of x can be written as, it's a common logarithm, the base is 10 now, it's a base is 10. So the logarithm of x to the base 10 can be written in this form. The logarithm of, I can write this, the logarithm of x can be written as, it is ln x over ln of 10. I can write this in this form just by giving the same base, that is logarithm of x the base e, logarithm of 10 the base, that means. So using this, please try, students, this one, and try to integrate this expression. The integration of ln x over ln 10 dx. Please try this one. Okay, so just taking 1 over the outside, you will have integration of log u du. So the integration of this, just we have solved earlier. So we have this 1 over 2, 1 over ln 10 times u ln u minus u plus some constant c. As you remember, just we have solved the integration of log x in previous example. It is x ln x minus x, so times 1 over ln 10. Therefore, the integration of this one, it is 1 over ln 10 times u ln u, the variable is u here, u ln u minus u plus some constant c. So this is not the final answer. You have to change the variable u because the question is in terms of x. So let's change that. Substituting the value of u by 2x plus 5, you'll have this one. It's 1 over 2 times 1 over ln 10 times u is this 2x plus 5 times ln of 2x plus 5 minus, in place of u, this one, 2x plus 5 plus some constant c. So you can factor out 2x plus 5. So factoring out 2x plus 5 times this 1, it is 2x plus 5, 2 times ln 10 is 2 ln 10. So the remaining here, it is ln of this one. It is ln of 2x plus 5 minus 1. So this will be the final answer. Okay, good. Now let's proceed to other example. Look this one. The integration of x to the power of r ln x dx. Let's try to find the integration of this expression where r is any real number, but different from -1, different from -1. So as we stated earlier, when you face such type of expression, assume u to be ln x. So here, assume u to be ln x, so u is equal to ln x, and dv by its x to the power of r dx. So from this, you can find du, the derivative of the expression, 1 over x, and the antiderivative of this expression, it is x to the power of, it's a power function, it is x to the power of r plus 1 over r plus 1. So the integral of this function will be the product of the two minus the integral of the product of the two. So you'll have this one. The integration of x to the power of r ln x dx is equal to the product of the two, it is x to the power of r plus 1 over r plus 1 times ln x minus the product of the two functions. It is 1 over x times this one. So simplifying this, you'll have this one, this as it is, minus, you can factor 1 over r plus 1 outside, and the ratio of these two is this x to the power of r, x to the power of r, x to the power of r plus 1 over x is this x to the power of r dx. So finally, you will have this one. This is as it is, right, as it is, minus 1 over r plus 1 times the integration of x to the power of r, is it's a power function, x to the power of r plus 1 over r plus 1 plus some constant c. So this will be the answer, just multiplying these two, r plus 1 times r plus 1 is this, r plus 1 the whole squared. So this is the final answer. Now, what would happen if r is -1? R is -1. So try to evaluate this integration. This integration of x to the power of r times ln x dx is equal to, for r minus 1, it is x to the power of -1 ln x dx. So this is it. So to integrate this, you will not use integration by part. So we will use other technique because you can write this expression in this form. X to the power of -1 is this 1 over x times ln x dx. And when you derive this function ln x, it gives you 1 over x. When this happens, as we said in previous lecture, you have to apply integration by substitution technique. So let's apply that. So let u be ln x. So du by dx, the derivative of this one will be this 1 over x. So take dx there. So du will be 1 over x times dx. So substituting du in place of 1 over x dx and u in the place of ln x, you'll have this one. So 1 over x times dx substituted by du, ln x is substituted by u. So this will be simple to integrate. Simply u times du is a power function. So it is u the power of 1. You add 1 on its power and you put the power in the denominator. So the answer will be this, u squared over 2 plus some constant c. But this is not the final answer. You have to substitute the value of u. The value of u is here, it's ln x. So when you substitute the value of u, this ln squared x over 2 plus some constant c. So this will be this, the final answer. This is the final answer. Now let's add more example. Let's see this one. This example is a little bit different from the previous examples. So please just listen me attentively. So as we listed on the guideline, when you face such expression, you have to let u to be the trigonometric part and dv to be the other part, e raised to x times dx. E raised to x times dx. Therefore, from this, you'll have this one. The derivative of u is this cosine of x, and the antiderivative here, you have to list the antiderivative. That's the antiderivative of this expression. It is the integration of e raised to x itself times the reciprocal of this coefficient. The reciprocal of 2, it is 1 over 2. You have to put 1 over 2 there. So v will be 1 over 2 times e raised to x. Therefore, this integral will be the product of the two and then minus this one. Therefore, the product of the two is half of e raised to x times sin x minus the product of the two. It is e raised to x times cos x. Just take half outside. So 1 over times integration of e raised to 2x cos x dx. Okay, this is the final answer for the integration of x to the power of r ln x dx. This is the final answer. So this is all about today's lesson. Please, students, read more example from your textbook and do more exercise on your textbook. In addition to that, please try the following exercise. Try this exercise. So that's all about for today. I'll see you on next lecture. Until then, goodbye.